Students, in last class I forgot to explain one point, that is the difference between distance and displacement. For example, from point A to B, when an object travels and returns back, if the distance between these 2 points is 15 meters, to travel from A to B 15 meters and B to A is 15 meters, the time it takes, the length it takes. But remember, while we measuring distance, the total distance will be from A to B and B to A. That means when an object moves from A to B and returns back from B to A, the total distance is 30 kilometers. But whereas the total displacement is 0 kilometers. Why is it 0? Because the object when travels from A to B, it will take 15 kilometers, and back from B to A means it is changing the direction to opposite. When it moves in opposite direction, the distance will be minus 15 kilometers. So the difference will be 0. So when during displacement, object changes its direction. During displacement, when object changes its direction, the sign also changes. That's a vector quantity. But a distance, scalar quantity. Here, when object changes the direction, but it won't change its sign, because the scalar quantities have no directions. So when it returns, when it reaches to initial point, the distance remains as the total length of path only, but the displacement remains 0. This is what I forgot to explain. Now we discuss about uniform motion and non-uniform motion. So uniform motion means the motion of object which repeats at every regular intervals. For example, if motion of planets, motion of hands in a clock, these are all uniform motion. These are all uniform motion. So these are all uniform motion, because in these examples you see motion of planets. For example, Earth is a planet. It revolves around the sun. So to make one complete revolution around the sun, it will take an year time. For the next revolution, it will take again an year. So with a constant interval of time, the motion of body is repeating. This is uniform motion. And non-uniform motion, there is no particular time interval, and there is no rule to be repeating the motion of a body. Here, the motion of body will change and is not constant. For example, a bus on road. A bus travel in a city, not on the road. While a bus travels in a city, the speed it travels, the distance it covers with respect to time. It is not a constant, we cannot say, because that depends upon traffic conditions. Wherever the traffic is more, there it covers less distance with time. If the traffic is cleared, it travels more distance with respect to time. So that it is a non-uniform motion. The swinging of fruits on a tree. The fruits will swing when the wind happens, but this time we cannot say a particular distance, a particular time interval it will cover. So these are all non-uniform motion. The reason to discuss this uniform and non-uniform motion is we have conditions, we have various types of speeds regarding this uniform and non-uniform motion. Regarding the uniform motion, we have the speed and the velocity are uniform speed or uniform velocity. Next, instantaneous speed or instantaneous velocity. Instantaneous speed or instantaneous velocity. Average speed or average velocity. So uniform speed or uniform velocity means what? If the object is able to cover equal distances or displacements, with equal intervals of time. For every regular interval of time, if the object is able to cover same distance and or same displacement, then it is said to be uniform speed or uniform velocity. Instantaneous speed is also a kind of uniform speed, which is said at the very instant time when object begins its motion is called instantaneous speed or instantaneous velocity. And average speed, see, this average speed we can also define in a non-uniform motion, because in non-uniform motion, once again we see what kind of velocities we have are initial speed or initial velocity, final speed or final velocity, average speed or average velocity. So here also we have average speed or velocity. What's the difference between the two? See, it belongs to uniform motion. Means what? See, if the object is traveling from a point A to point B at a speed of 40 km per hour, and again it continues to move from B to C with a speed of 60 km per hour. See, A to B it travels with a certain speed. The speed is definitely uniform speed. And similarly, B to C is again it is traveling with a certain speed. It is also said to be uniform speed. Two regular uniform speeds. But what is the total average speed taken to travel from A to C? This one whenever we want to find out. Then the total speed and total approximate speed that takes from A to C is being called average velocity or average speed in uniform motion. How can we find? We have a formula that is total distance by total time. So total distance by total time. So if in case of non-uniform motion, so in case of non-uniform motion, you want to understand, we just need to know about these words: initial velocity is or speed, final velocity or speed. See, in non-uniform motion, we have some other kinds of velocities or speeds. What are they? In it, the other kinds of speeds or velocities exist. What are they? Means regular, so irregular, speed or velocity. So when object has a regular speed or velocity, it never maintains a constant speed. Speed rises, falls randomly and irregularly. It changes. So it moves with 30 kilometers per hour. In immediate second it goes to 50, and again the next second it can fall back to 20, like this, without maintaining a regular order of speed or velocity and an object travels. This is irregular speed or velocity. But we have accelerated speed. See, with the uniform intervals, that means with the regular intervals of time, the distance it is going to be covered increases. Like what? In 1 second, in case it travels 1 meter, when one more second travels, it can cross 2 meters. When another second travels, it can cover 4 meters. Like this, with the regular intervals of time, the distance it is going to cover is going to be increased. This is accelerated motion. Similarly, in reverse condition, we can find a decelerated speed or velocity. This time what? It happens in reverse. In 1 second, an object which is capable of covering 4 meters, in the next time of 1 more second, if it is able to cover only 2 meters, in another second 1 meter, like this. So it is a reducing way of speed. This is called decelerated speed or velocity. So in these both cases, we are able to find two kinds of speeds or velocities. Those are called initial speed or velocity, final speed or velocity. Initial speed, in beginning of the motion, whatever the speed it maintains is initial speed. At the end of the motion or at the peak position, the velocity it has a final velocity. To give clear definitions, what we can say is, suppose the change is happening, change in the velocity is happening. Before beginning the change, what is an object's speed or velocity is called? Initial speed or initial velocity. After the change, the speed it has is a final speed or final velocity. This is it. Okay, now average velocity. See, the average velocity is being said as initial velocity plus final velocity by 2. That is the mean of the two kinds of velocity. Symbolically, initial velocity is defined by u, final velocity is defined by v and by 2. So average velocity in non-uniform motion is u plus v by 2. This is the average velocity. Okay, so this is what we can understand from it. And now, so I want to add little bit explanation to acceleration. In acceleration, previous class the definition is said change in velocity with respect to time. See, wherever the change in velocity is going to be happened, so there I said during the change, beginning time we have initial velocity, end time we have a final velocity. So change in velocity means is none other than the difference of final velocity and initial velocity. So we can define it as u minus v by delta t. So if u is greater, that means v is smaller. So sorry, I forgot. Final velocity symbol is v and initial velocity symbol is u. So this is wrong. So v minus u by delta t. If final velocity is greater, initial velocity is smaller, that is accelerated motion or accelerated speed. This time v is maximum, u is minimum. So the acceleration we obtained is positive. So we have that positive acceleration. But if v is a minimum, u is a maximum, that means in decelerated motion, u is greater than v. Initial velocity is large. In this time, the acceleration we get negative. It is called retardation. It's called retardation. And one more I need to explain is when an object starts from rest, u will become 0, come to rest, u will become 0. So when object starts from the rest, initial velocity is considered 0. When it comes to rest, final velocity will become 0. Okay, this is today's class. In next class we discuss the equations of motion.